So my name is John Gardner, and again, thank you for joining us here for Cisco ACI Multisite. First thing I want to do is just a quick introduction. So the session overview, and yes, John Gardner. The session overview, what we're going to be talking about is essentially what exactly is application-centric infrastructure, first and foremost. Then we're going to talk about what an application policy infrastructure controller is. And the reason why we want to talk about those two first is because those are kind of the linchpins on what multi-site operates on top of. So very important that we understand those two things before we get into multi-site. I also do want to talk about the evolution of application-centric infrastructure to show us how we got here. And then lastly, I want to, obviously talk about multi-site. What are our different components? What's a multi-site orchestrator? What's the benefits? Why do we have this whole multi-site thing to begin with? Now, the target audience, I would say anybody who's interested in cloud, data center, or if you've already got an application-centric infrastructure and you're looking to expand out, okay? Okay, and we already went through that. So let's go through just the quick agenda. So again, what exactly is application-centric infrastructure? And then what are some of the benefits? And then what are some of the components? So let's dive right in here, folks. All right, so what exactly is ACI? The first thing I want to talk about here, folks, is the application-centric infrastructure is a fabric that we can connect devices to. And I'm sure you're used to seeing, core access distribution, that kind of stuff. What we've done is we've modified that. I like to think that we've improved it into what we call a Spineleaf architecture, which I'll be talking about here in just a minute. The Spineleaf architecture is absolutely fantastic because what it allows us to do is we have these essentially hops where one device is only going to be maybe one hop away from another device. So this leaf is just simply one hop away from the other leaf. With that being said, when we talk about our Klaus architecture, which it's commonly referred to, we have what are called leaves, and then we have our spines. Now keep in mind, anything that you're going to plug in with ACI, you got to plug into the leaves. For now, we'll get into that a little bit later. So the whole point of building this fabric is so that we can start supporting things like multi-tier applications. And I kind of want to take a sidestep here and explain what exactly a multi-tier application is. A great example is if you go to check, let's say, your bank account, right? When we go to check our bank account, the first thing you're going to do is go to a web server, right? So we've got our web server over here. And so, let's say fifththird.com, right? Whatever. That's when the website pops up. You're at an actual web server. But what happens if you want to log in, check your account and all of that? Well, you're going to have some sort of authentication. Now, if you're familiar with LDAP, Lightweight Directory Access Protocol, that's Active Directory or it could be Linux. But what it allows us to do at the end of the day is authenticate that user account. But here's another thing. What about all of those transactions? Well, they're not held on the web server because a lot of people got to go to that web server every day. It's not held on the LDAP server because that's pretty much just for authentication. So we usually have this third tier called a database tier. This could be a SQL server, so on and so forth, Oracle database, but it's what holds all of your information. Now, traditionally, for me to get that to work, it was not fun. I'll just put it that way. It was very arduous. The reason being is because there were a lot of VLANs, firewalls, load balancers, SSL offloaders. Those were all in the way. So we had to point towards the firewall, point towards the load balancer. And these were all done with things like routing protocols, static routes, and VLANs. Now, the problem with that is the fact that if we continued to do that, our routing and switching infrastructure would really be bogged down by that large configuration, and not to mention two big things. You're error prone to building out that configuration, and also how often do you remove a configuration once that client or that server is gone? So let's insert application-centric infrastructure. What application-centric infrastructure is allowing us to do is to build these multi-tier applications anywhere on this fabric. And that's the beauty of it here, folks, is the fact that I'm not tying a server, a specific server, to an interface anymore. It can live anywhere on the fabric. That is the #1 advantage here. Now, we can also support traditional applications like just a standard web server. Absolutely. And what about virtualized applications? We definitely support things like Kubernetes, Nutanix. We can also support your containerized systems like Docker. Absolutely. Excuse me. Now, the big thing here is that it is open source. And what we mean by open source is that it has the ability to communicate and connect any vendor, right? Any vendor. I don't care if it's an F5 load balancer, Citrix NetScaler, Palo Alto firewall. You want to plug in an HP ProCurve switch into one of these leaves? Go for it, right? Because all we care about here in application-centric infrastructure is the application. We're moving away from certain traditional paradigms, which again, I'm going to get into a little bit later. Note that we also do support the physical and virtual endpoints. So our virtual endpoints, what are those? Those are going to be things like VMware and Hyper-V. So I can absolutely support my hypervisors that you folks already have implemented. But the biggest thing is the policy abstraction. That is the #1 goal of application-centric infrastructure. We want to get away from what we call box-by-box configuration methodology. And let's go ahead and bring up that really expensive whiteboarding utility that I use all the time here again. And let's kind of show you the difference here. So in a traditional architecture, what you were seeing was we would have a server, and it was probably plugged in redundantly, hopefully. But here's the problem. When you configured that server, you had to configure these two interfaces to be in a VLAN. Then you had to configure all of these interfaces for trunking. Not to mention, you also had to allow the VLANs. Oh, but what if the device wanted to talk to another subnet? Then we're going to have to insert routing. And then you're going to have to configure the router for routing between those different subnets. Now, what application-centric infrastructure is doing for us now is instead of configuring all of these interfaces here, what we're going to do is we're going to create, and actually let me say outside, what we're going to create here is what's called an application network profile. Now that application network profile, instead of being configured on every single interface, imagine it's just floating around, right? And so when we plug something into our infrastructure, let's just say that we plug in our server here, the architect or the infrastructure has the ability to identify what application is going across these interfaces. And you know what's awesome? Is it looks at this application profile and says, what should I do with the traffic? And it configures it on demand. And let's say you remove that server. Guess what? Now the configuration's gone. So we're running lean and clean. So this is fantastic. What we're trying to do is we're trying to abstract the configuration from the interfaces. We want to be able to have this configuration living somewhere else so that we don't have to configure everything every single time something touches our fabric. So with that being said, Where is all of that done? This guy here with the face to the place one time. The application policy infrastructure controller, the APIC. This is truly the brains of the operation. And so if we go back here, the APIC, let's use this one. The APIC sits inside the fabric, and anytime one of these leaves sees a traffic pattern, it asks the APIC, the application policy infrastructure controller, what should I do with this traffic? Well, the APIC is where we've configured our application network profile. So what it does is it simply tries to match the traffic pattern. For instance, let's say that it's coming from the outside. Okay, that's a horrible router. Here we go. So let's say that it's coming from the outside. If it comes from the outside and it's trying to go to a web server, do we have a policy that permits that? We absolutely do. So do whatever that policy says. So if we say permit that traffic, it will permit that traffic. Note, the only thing I did here was create an application network profile and let ACI do its thing. Now moving forward here, excuse me. So here's our Spineleaf architecture. Just a couple of quick things about this. If you folks are familiar with Fabric Path, it's very, very similar to Fabric Path. What we've done is we've created a high-speed fabric with 40 gig connections, 100 gig connections back here on the integrated overlay. So it is a very fast backplane here. You have a minimum of 2 spines. Now, the reason why we have 2 spines, there's actually a couple of different reasons, but the spines are the backbone. You don't want one and have that backbone go offline. Then you're going to have a real bad day. So leaves never connect to each other. That is absolutely correct. There's actually 2 things, LLDP and the miswired configuration protocol, that watch for that. And if it sees it, it'll shut down those ports. Devices. Now, since we're talking about multi-site, this isn't so true. But up until the 2.0 series, you could only connect devices, servers, routers, other switches into the leaves. Today, we're going to talk about the 3.0 series of ACI that does support multi-site. Now, again, the Cisco APIC, this again is the brains of the operation. All the way from creating the application network profile to building the actual fabric itself. So whenever you kick off a discovery of the fabric, which I want to mention, just so you know, you don't have to configure these links. All you do is discover these devices and they build them themselves with the information that they get from the APIC. So what is it holding? Basically management information. Think of it this way. If you've ever copy and pasted a configuration onto an interface, right? Imagine instead of you copying and pasting it from a file server to the interface, imagine if that file server said, oh, do you need this? That's exactly what the APIC does. So it holds management information, but it is not a control plane. These leaves and spines, they still do their own thing, right? They still have their own control plane. You can still connect to these devices and configure from the CLI, for instance. Absolutely. Also, keep in mind that if you're going to have one controller that controls the entire environment, again, that's a single point of failure. We're probably going to want to have multiple. So generally speaking, we have 3 or more, but it could run in one, but that's a whole nother bag of worms. The biggest thing here, folks, is that it instantiates policy changes. So let's say that a new customer jumps into our environment. All we have to do is create a new application network profile, and then bada bing, it's instantiated onto the fabric as soon as it's needed. Decoupling endpoint location and policy. This is one of the biggest things for application-centric infrastructure, whether it's single site, multi-site, single pod, multi-pod, it does not matter. What we're trying to do is we want to remove the need to map a device to a specific interface. That is really the biggest subject that I would discuss, especially in a full-blown course for ACI. So endpoints, what we're going to do is we're going to identify them based upon their IP and MAC address information. So just like a normal switch, what's the whole point of the switch? It's not to switch. It's actually to learn endpoint location. That was the big difference between hubs and switches. So with these switches, the first thing they're going to do is learn IP address and MAC address information. Yes, I said it. Think of these as multi-layer switches. They can do layer 2 switching. They can do layer 3 routing all day. So they learn the IP and MAC info. Then what they do is they update that information to these spines so that the spines know the location of everything. But we're going to do something very special here that's very, very different than what you've probably seen in traditional architecture. We're actually going to map it to a virtual tunnel endpoint, which is essentially a VXLAN source and destination. If you've ever done like GRE or IPsec tunnels, you know that you have a source and a destination that you've got to configure. That's exactly what the VTEPs are. Our virtual tunnel endpoints are that source and destination of the traffic. We just simply build a tunnel between them. So forwarding does occur between the VTEPs, absolutely. Transport is based on VXLAN header information. That's going to be things like your VXLAN tunnel ID. And there's some ACI stuff in there that gives us a good idea of the policy that we're trying to instantiate. Excuse me. The last thing here is distributed reachability database maps endpoints to VTEP locations. Let's decipher that. What that means is whenever we learn a new endpoint, like I said, we're going to update that to the spines. On the spine, they have an Oracle database called COOP, the Cooperative Oracle Protocol. And what it does is it essentially, anytime I learn a new device location, I'm going to go ahead and update that or synchronize that across all of my spines. This is fantastic, especially if you're looking for a device and let's say you're ARPing for it and you don't know where it's at. You can ask the spine, and the spine probably knows where it's located. Now, with that being said, that's a quick primer here, 20-minute primer on what application-centric infrastructure is and what the fabric is and what the APIC is for. The reason why I talk about it is, notice, the only thing you see here on the slide is the fabrics and the APICs. Very, very important. When we first started, back in the day when dinosaurs roamed the earth, we had ACI 1.0. And this is actually where I did get started. When we started with leaf and spine architecture, we only had a single pod. What that meant is that just like any other sort of fabric that you see, you usually have like some sort of routing protocol or some protocol that keeps track of it. That's what a single pod means, is that we only have one instance of that protocol. For your information, that's actually intermediate system to intermediate system. Well, we started noticing that, you know, most companies and customers didn't have just one location, right? They had multiple locations. And the problem was that we had to start taking a look at configuration consistency. I needed the configurations and policies to be the same across multiple data centers. This was super important. So what we did was we created what was called a stretched fabric. Now, again, this is just a single pod running ISIS to keep track of where all the locations are. But I also want you to note here, these APIC cluster. Remember those 3 APICs we were talking about that control the fabric? What we were doing was we were maybe putting 2 APICs at one location and another APIC at another location. We were stretching the administration or that cluster across 2 data centers. Now that was fantastic because now at this point, all I have to do is create a configuration on one APIC, and it will instantiate across the board, which was pretty cool. Now, back in those days, what we had between the data centers was what we called an IPN, an inter-pod network. We still see that. You actually see that here in multi-pod, multi-site. But it was all usually plugged into the leaves, okay? And again, it was just one fabric, one cluster. The problem with one fabric and one cluster, it doesn't provide me redundancy, right? What happens if one of these pods or data centers fail? Well, one data center failed. So what we started doing was in 2.0, we supported the multi-pod. Now, what multi-pod means is that these two act independent of each other from a fabric perspective, but have a consistent policy model between them. I also want to mention here that note, we are plugging stuff into the spines now. That's right. We're going to plug in, maybe an ASR 9K, a couple of ASR 9Ks at each location. You're going to build some OSPF networking between them, and then you can plug in your inter-pod network. Now, again, keep in mind that these are now two separate fabrics. It's not one. So I could make it to where if this fails, we could simply fail over here to another pod. I want to mention also that this is in one data center. This is a singular data center in multi-pod. If we go over here to the 3.0, the 4.0, and now the 5.0, which is out, APIC, it supports what we call multiple zones, availability zones, basically stating that this is its own fabric and its own APIC cluster. Right, so they are completely independent of each other. So we're not inside one building with a stretched cluster. We are completely independent of each other. Now, the first question that always comes up is, but John, that means that I have two clusters that are independent of each other. How do I keep that configuration consistent? Isn't that the number one thing that we want here? Absolutely it is. That's why you might not be able to see it here, but that's why we have what's called the MSO, the Multisite Orchestrator. This is a fantastic utility that allows us to hook in. And by the way, all you need is IP address and credential information. And you simply, in the Multisite Orchestrator, add these two sites. Now, at this point, whenever I create a policy, it pushes down to both. So they're mirror twins of each other, which is absolutely fantastic. Now, moving forward here, what are some of the components that we're going to be seeing? The biggest thing here, folks, is the interpod network and how is it actually communicating back and forth. The big thing here is that this can be any layer 2, layer 3 environment, but what we're going to be sending across here is this is going to be acting like an Ethernet VPN, a layer 2 multi-protocol BGP EVPN. The reason why we need multi-protocol BGP is in the event that you folks add something new to each one of these fabrics. Multi-protocol BGP will send that information between the locations so that we know about all of our available subnets. Now, another thing is this inner site control plane between here. That's all handled by the Multisite Orchestrator. I want to mention that normally we connect to it via a graphical user interface, but if you folks are familiar with something called Postman or Python, we can absolutely send programmability scripting over to this Multisite Orchestrator. This is great because now not only can we replicate policy to the Multisite Orchestrator, I can also use the REST API to talk to multiple MSO instances. So as you can see, this consistency just keeps building on top of itself. Now, in this example, this is a pure layer 3 transport. This can, like I said, this can be anything layer 3. What we're doing across there, if you're familiar with VXLAN, we have a layer 2 and a layer 3 version of VXLAN. Here in this multi-site design, we're actually using the layer 3 version. So just a quick primer. I should probably explain just real quick what VXLAN is. Very, very important. So let's go ahead and draw a router here really quick. And a couple of switches. Oh, okay, somebody dropped that one. Sorry about that. So we have VLAN 11 and we have VLAN 11. Now, anybody who's been doing routing and switching for a while, you probably already know that things like broadcasts are not going to go across here. Why? Because it stops at this router's interface. So what VXLAN allows us to do is it allows us to create a tunnel between these two interfaces on the layer 3 device so that we can enter the tunnel and leave the tunnel so that it feels like this is just one big switch. Now, what's kind of neat is if you look at the leaves here in ACI, that's exactly what they are. There's a little router and a little switch inside of them so that whenever these two leaves are talking, you know what they're actually doing? This is VLAN 11 now. This is VLAN 11 now. And we're just simply creating a VXLAN between them. So at this point, this layer 3 environment can be anything. It's layer 3. We're just simply creating a tunnel. Very similar to like a GRE tunnel, if you're familiar with the generic routing encapsulation. It's very similar to a GRE tunnel. Very simple, very easy. It's just got a tunnel ID, call it a day and go. All right, now, the multi-site orchestrator. I just wanted to give you a quick glimpse into what the multi-site orchestrator looks like. One of the things is, yeah, you're going to have a dashboard, which is really cool because it shows you everything. It is very, very in depth. Here, this is actually showing the site status. So you can see there's a couple of sites that look like they've got some critical errors and a couple that look like they're fine. But the thing to note here is that these are still up. This is just simply showing you the sites and if any sites have any issues. Now, if I clicked on sites here, hey, all I have to do is put in the information for the APIC. Boom. Now we're going to be using an API to talk from the multi-site orchestrator down to your APIC. You can also create schemes or policies. You can also create tenants. The users, that's for basic administration of the multi-site orchestrator. Now, a couple of other things that we want to talk about here is I did want to show you that, you know, I know everybody's sitting there going, oh no, my policy, my data is going across the series of tubes, the interwebs. That's not good, right? We want to look at something like IPsec between there to provide some security and integrity. Well, what's really nice is not only do we have, well, let's start over here with our VTEP information, right? So we define the source and destination VTEPs, right? We're going to define that so we know where to send the information back. But then we also have our VXLAN header. That's going to give us the tunnel info. Then we have two really neat things here. CloudSec, cloud security, and MACsec. I know you don't see that here, but yes, we do have a layer 2 encryption and a layer 3 encryption, MACsec and CloudSec. Absolutely fantastic. So just a quick heads up, the APIC is in charge of pretty much all of the, not the actual encryption itself, but holding certificates and encryption keys, so on and so forth. The actual leaves and spines do the encryption themselves. In this case, obviously, it would be the spines. Now, I did want to see, or want you to see that, again, whenever we update information here, or whenever we add a device, what happens is that leaf will send a COOP message, a cooperative Oracle protocol message, up to the spines. Now, what's really, really neat is before, that information would just stay here, right? It would just stay in its local site, but we're in multi-site now. So what's very, very important for us at this point is to be able to update that information over to the other side. And yes, guess what? That's done with COOP. It's a COOP message encapsulated in the VXLAN header and sent across that interpod network, okay? So that means that at this point, each one of these spines, check it out. It knows about all of these different devices connected to either site. Very cool. Now at this point, since I know where all of my devices are located, I can now start building a policy that says, do I want this endpoint to talk to this endpoint? Now, that leads into the next thing, which is contracts for multi-site. Contracts are very similar to what you are familiar with your ACLs, your access control lists. Can't be any simpler, right? It's just now, instead of you sitting down on each one of these devices and pounding out ACLs all day like we used to do, right? What's really neat is if I see this endpoint talking across here to the other endpoint, it installs that ACL for me automatically. And you know what's really even better is it creates like an inbound outbound ACL right here on this interface and this endpoint 2 interface. You didn't do anything, right? It just allowed that traffic because the application profile that we created permitted it, right? Very, very neat. And again, I do want to mention another really neat part about application-centric infrastructure is the fact that if I remove this endpoint, it removes all that mapping on this leaf for me. That's going to conserve memory and CPU for us, which I think is pretty awesome. Now, what about inserting things like firewalls? Right? Okay, I want to plug a firewall into my environment. There's this thing that we do called service graph insertion. And what this means is, let's say that endpoint 1, endpoint 1 wants to talk to endpoint 2. What I can do is I can put a point to a firewall here in the contract. And what it does, and this is this term is actually used a couple of different places. It's used here for policy distribution, but it's also used for policy enforcement for L4 through 7 devices. Whew, say that twice. But it creates what's called a shadow EPG. What it means is that when, let's say endpoint 2 needs to talk through a firewall, we create a shadow EPG between them to keep track of the source and destination. Right? Because otherwise, if you think about it, we're just, oh, yeah, go over to here's this firewall. I don't know what to do with it next. By creating the shadow EPG where the firewall is located, it can see where the inbound interface is and where the outbound interface is, thus keeping track of where endpoint 2 came from and where it's going to on endpoint 1. So the shadow EPG, by the way, folks, this is something that you don't have to configure. You're never going to see. It's something that runs under the hood. It's that secret sauce inside the APIC that allows the communication across L4 through 7 devices. So your firewalls, your load balancers, your SSL offloaders, these are all very important devices that we want to connect to the network. Okay, so with that being said, I'm going to go ahead and open it up for questions for the next few. Oh, beautiful. So Kareem is asking, are there any limitations regarding the maximum number of endpoints? That's a beautiful question. So endpoints, EPGs, multi-site orchestrators. So the multi-site orchestrator, that's a thing on its own. You're usually only going to have one or two per your global environment. Number of endpoints, that is actually determined by the number of APICs that you have at each site. With 3, we started 1 million endpoints. Endpoint groups, I got to look that one up, but I think that's like 4,000 per tenant, and I can have 1,000 tenants per a 3 APIC architecture. So if you have like, I don't know, 7 APICs, you could probably have 8,000 EPGs with 4,000 endpoints, right? It's the number of APICs, really, at the end of the day. Good question, Kareem. Thank you. Amr, okay, so can we create service graph between 2 EPGs, each located in each site? Absolutely. Let me, maybe I can open up another one here. No. Okay. Actually, hold on a second. I'm going to show you that here really quick. Excellent. Okay, so if I have 2 sites, and let's see here, a service graph between 2. Okay, yeah, that's fine. So I'll go ahead and draw a firewall in one location. So we've got a firewall in one location. Okay, this is my efficiency mechanism for drawing a fabric. Don't need to be too pretty. It's a spaghetti mess anyways, right? All right, so if I have 2 endpoints here, so we'll call this a client and a server. You absolutely can. And here's how this is going to work. I mentioned we were going to have our ASR 9 case here. Those guys are connecting the sites together. A lot more drawing than I anticipated. And then you have your cloud here. Now, these things, not super important except for the transport, right? This is just transporting the data in the policy. What you've done is you went to the Multisite Orchestrator, MSO, and you created something like, we'll just say a client EPG to the web EPG. And in between those, you have this contract. Inside the contract, all I did was specify the IP address of that firewall. As long as I permit this traffic from client to web, I'm going to forward it or redirect it over to that firewall, okay? So with that being said, when you create that on the multi-site orchestrator, what's happening is, I'm just going to draw one APIC at each location. It pushes that config down to these 2 APICs. Now keep in mind that all of these spines know where this firewall is. So whenever let's say the client is talking to the web server, the policy states that yes, the traffic is permitted. Let's go to the firewall on its inbound interface, through its outbound interface, and at this point right here, it does an endpoint lookup, and that's where it's forwarded up to the spine. We use OSPF here to identify the destination network, which is actually this one. And then we encapsulate it with VXLAN to go across. Now, when it hits this interface, all of that information is stripped off, and it looks like the original frame that the client sent. The spine simply does an endpoint lookup. On the way back, oh no, there's no firewall over here. Oh, what should I do? Well, guess what? whenever it hits this interface, we do a lookup. This spine, if you remember, it already knows where the firewall is, so it packages it up. And another thing that I should also mention here, Amr, is that there is policy information that is inside of the VXLAN header. It's called an SG, source group tag. It tells me where the source and destination EPGs are, right? So these are EPGs, endpoint groups. It submits that information. So that information is already encapsulated. So whenever it gets to the other end, all it's doing is looking for the firewall, just like before. Okay, it'll go to the in port, out port, look up the end node, bada bing, bada boom. Very good question. I'm not sure. Okay, so flow in firewall, inside, and then outside from web. Amr, yes, correct. vMotion, yep. Oh yeah, sorry, you you got me. You got me, Amir. Amir, you got me. You are correct. You are correct. Because this is zone-based firewalling, right? Right? You got me. Sorry. You are absolutely correct. So like if it's coming from, let's say this is a client on the outside, yeah, it will come, it will hit the outside interface of the firewall. So yes, zone-based firewalling still applies. I also want to mention, very, very good. I'm very glad you picked that up, because when you build this service graph, when you do policy-based redirection, you actually specify the outside and inside interfaces. So not only are you defining that on your zone-based firewall, the APIC, the ACI fabric knows what port on this leaf the outside interface is and inside. By the way, we do support also single attached zone-based firewalling, so it doesn't have to be two. I could have a firewall over here, just plug inbound, outbound, right? I also want to mention, Amir, that we do absolutely support firewall clustering of physical firewalls. And if you have ESXi, we can absolutely support like your virtual load balancers, your virtual firewalls, so on and so forth. So very, very good catch on that one. That led into a very good topic. Yeah, and Amir, with vMotion, yes, absolutely. Because again, this is going to look like layer 2 traffic because it's an Ethernet VPN, right? An eVPN. So we don't touch anything. You know, it's like, let's say I'm going to send my phone in the mail. I don't do anything to this phone, right? I put it in an envelope and I address it so that when, you know, somebody gets it, oh, cool, it's the same phone. Same rule applies with vMotion. Absolutely. Oh, were you talking about the leaves? Well, you were mentioning end nodes. Okay, here we go. Oh, and I'm sorry. Yeah, Kareem, I was referencing like a single APIC cluster inside of a single location. My bad. Yeah, 100,000. I guess that is the full max, but this is for the 3.1 multi-site release 1.2 release 3.1. Ooh, I wonder what it is for the 4 and 5, because maybe that's what I was reading. Let me check here. Do they have, let's see here, APIC 4.0. Yeah, it looks like it is still 100,000. Okay, so yeah, I guess I missed it by 1 digit. But yeah, like the bridge domains, the EPGs, you know, 4,000 for stretch cluster. Oh, okay. Well, that went. I think that went up. The number of L4 through 7 devices that are supported. But yeah, so yeah, I will verify that that is 100,000 for the stretched cluster, the multi-site. Now, are they assuming that there's only 3 APICs? Because again, oh, stretched objects. Okay, so what a stretched object means is, let's say that I have web servers, right? So if I have this web server over here, right, they would be in, you could make it to where they are in one endpoint group. So the policy for this web server is exactly the same as this one. It's the same. So that policy is stretched across the 2 fabrics. So that could be bridge domains, EPGs. Awesome. It's not often that I see people use the thumbs up, but that could be EPGs, bridge domains, VRFs. Yeah. And for anybody who's jumping out right now, we really appreciate your support. We really appreciate everybody jumping in this morning. Thank you so much. If you would like to take a look at our ACI, our data center, we have some really great classes with collaboration and Unity and all of that. We've got Python courses. We run the entire gamut, right? If you guys would like to take a look at sunsetlearning.com, you can get more information on training, or you guys can go ahead and shoot us a call. A bunch of 8s, 5251. Thank you, guys.